So I just wanted to quickly dive a little bit closer into this idea of residual covariance and uh, heterogeneous residuals. So first, I'm going to open up the PDF version of these slides where I fit this model with residual covariance. So you see here I call core AR1, and that outputs this. It says it's called phi, but we treat this as the rho. This is the same thing as the rho parameter. And so the way we interpret this is if we can look back at the slides from lecture. Make sure I find the right page. There we go. So here we see this is an example of an autoregressive lag one structure. So you see along the diagonal, you have the residual variance, which is considered the same at each time point. But then in a normal design, we typically assume that the covariances between each time point would be zero. So this would be in a normal design, we would not consider the time points to be correlated. But when we have the autoregressive lag one structure with equal, as long as we have equal time points, we now say that the first time point and the second time point, which are the first and second diagonals here, those are the variances. We say that they actually are correlated by multiplying the variance times rho. Then we would say that the first and the third time point, so here we have the first versus the third time point, are correlated by multiplying the variance times rho squared, and the first and the fourth time point by multiplying the variance times rho to the third. So this is what the autoregressive lag one is. And so this rho in our example is equal to 0.14, and the residual variance is this is the residual standard deviation, so it's 3.5 squared.